Hello, everyone. Welcome to the Data Colada seminar series. My name is Joe Simmons. Today, our speaker is Leif Nelson, who is usually the one doing all the introductions. So we're very happy to have convinced Leif to present today. He'll be joined by some excellent panelists that we're very lucky to have: Jessica Flake, Don Moore, Mike O'Donnell, and Liz Tenney. Okay, let me stop sharing my screen, and then Leif, you can get started.
Okay, thanks everybody for being here. Let me first see if I can successfully share my screen.
Can't hear you.
Why not?
Oh,
you.
Never mind. My fault.
Okay, well that works well.
If you mute your computer, you can't hear you.
Okay, it's a useful tip for the audience also. All right, let me see if I can get this right. Okay. Do you see my slides? Excellent.
Looking good.
So thanks to all the panelists for being here, and thanks to all the audience for being here as well. If you've seen this before, you can submit a Q&A through that function, and this is unusual in that you'll note that 3 of the people here are co-authors, and all of them are of the type that they will get bored if they can't type in answers in response. So consider it a low threshold. On top of that, all of that, it is Mike O'Donnell's birthday, and I'm sure he wants no greater gift than to be able to answer questions. So feel free to get those in there. Okay, so I'm going to talk a little bit about replications today. So this is going to be 2 different projects. I'll spend a little bit more time on the second one. And we'll sort of see how it goes. Okay, so short form. I'm going to talk about replications for about 60 seconds. I'll talk about some work I been doing with Joe that some of you might have read about. Then I'm going to talk about this bigger project that I did with Mike and Don and a bunch of other folks. And I'll talk about how it's related to basically trying to create an improvement on sort of standard approaches to literature review. And then I'm going to make really broad and encompassing conclusions about the whole field. Okay, so the background that you probably already know, it turns out in the last 10 years that the field of behavioral science has gotten pretty concerned about replicability. You could start here, where a medical researcher made the fairly severe claim that most published research findings are false, or you could go 10 years forward where this sort of landmark study was published, which was a replication of 100 studies in psychology, which had the claim that 36% yielded of those replications yielded a significant result. And effect sizes in the replications were considerably smaller than in the original. Okay, so those are our basics. And you say, great, that sounds like a serious problem. And so we then ask the question, why don't more findings replicate? What's the reason? And I would say that there's 2 categories of explanations. One typically fall in the category of what are at least articulated as comforting reasons. So in this paper, they argue that, well, actually, if you look at the replications in the right way, they're consistent with the original being true. This is essentially a statistical power argument that says there's sufficient imprecision in these replications that for many of them, a true effect is included in that confidence interval, which is fine, and there's other statistical approaches to thinking about it. But mostly I would say, if we're concerned about the imprecision of the replications, we should be deeply concerned about the imprecision of the originals. And then also they make the second argument that actually the people replicating these studies didn't do a good job. And for those of you who've read the Gilbert et al. Critique, they have some wonderful examples of things that look like imperfections in the replications. And here I would make the argument, if we're concerned that replicators are getting things wrong when they are trying as hard as possible, we should be concerned about the fidelity of anyone ever replicating or generalizing any finding. But again, it could be comforting. And then there's this one that argued that actually, no, it's the ones that failed are actually just context dependent. And this has been critiqued in a couple of ways, notably by Yoel Inbar. But even if we bought into the argument, we would then also say, wait, if we can't get the context, if we can't replicate it in the exact same context or as exact as possible, then what have we learned in the original? And then we have the discomforting reasons. Maybe the original findings might have been selectively reported. Maybe there's p-hacking involved. Maybe there might have been some fraud. And all of those lead to the idea that maybe some of those original findings were false, which, again, should be somewhat discomforting if we think that we're only publishing true findings. Okay. Now, I'm in marketing, which, for those of you who are not, is a subdiscipline in a business school that studies consumers or something like that. But I'm a psychologist. But the reason I care, or the reason we care, is this is my adopted discipline. And it's interesting to note that as the field reformed, consumer science, consumer research was sort of slow to get on that train. There's some. I'm not actually excessively critical. There have been some changes, but I note it in that I spent a while reading through every single editorial that's been written in the Journal of Consumer Research to find points where they acknowledge that replicability is important. So I'll just read these. It's going to take just a minute. This is from Kent Monroe, who says many, many years ago, if a strict replication confirms the original results, there's information gain, and that we now have two demonstrations of the outcome. Thus, while partial and conceptual replications offer an opportunity for more information gain, they're riskier, and that without confirmation, we're left in a quandary as to why there are inconsistent results. Indeed, in replications research, we're interested more in the sameness of results than statistically significant differences per se. Again, that's 1992, not last year, right? So this is the editor of the leading journal in the field saying, hey, wait a minute, we should really be thinking about how this is going to work, and replicability matters. And here's from David Miff saying, we must also cultivate our many tentative insights through re-inquiries of various kinds. Re-inquiries is his term for replications in this editorial. Otherwise, the intellectual equity of our field, passed on each year through textbooks, lectures, and seminars, will remain much flimsier than we'd be honest enough to admit. Again, 2003, a sort of serious self-reflective moment. And then this last one from John Dayton, who says, JCR owes most of its readership, its sponsorship, and its patronage to the expectation that its consumer insights are useful to marketing and the regulation of marketing. This is a little ambiguous because it doesn't sound like it's talking about replicability, but I'm going to have the somewhat hot take here that, so there's much bemoaning in psychology or in consumer research that no one listens to us. Why don't we have a seat at the table? And it's usually that we say, well, it's because we're studying such small arcana that no one listens. And I would have said, no, there's an argument that no one listens because of all the things that are in the other quotes. They're worried that our findings are flimsy and they won't replicate. Okay, which gets to where Joe and I step in. So while we were waiting for the whole field to move forward with replicability, we decided to try to replicate some findings to learn about the replicability of the field ourselves. Okay, so the way we approached it is we identified experiments that had been published in these two leading journals, Journal of Consumer Research, Journal of Marketing Research, over the past year. There's obviously lots of those. We looked for papers that contained an experiment that had been conducted online. That is because online samples are easier for us to replicate and without worry that something is different about the context of the population. And of course, most studies are online samples these days. We wanted one that didn't have any intrinsic design confounds. That meant we read the papers and we would say, all right, yes, this is a finding. It was online, but I'm concerned it has alternative explanations. So let's not use that because it's not a good test for what we're looking for. And at the margins, we would find the study in the paper that had the best possible evidence and also with the simplest design so that it's easiest to report and consider. For those of you who've read our blog, you'll know that we don't always land on designs that are particularly simple. In fact, they're often particularly complicated. So we did 10 studies. So we follow Yuri's guideline and say we're going to collect 2.5 times the original sample. But that's not how Joe does things. He finds that to be too low. So he routinely collects much more than that. So across the time, the original 10 studies had about 2,000 participants. we collected about a little over 17,000 participants in the different studies we ran. All the materials are posted, and we contact authors every time to ask them questions about small details in it, all of these things. Okay. We often run more than one replication because we're chasing down ambiguous leads in the data we collect. Fine. All right. These are the studies. I'm not talking about any individual ones. I just put them here so that if you're in the audience and you're like, oh my God, my name is up there, or I know that person, that you can feel a little more invested, something like that. Okay, but that's all. That's the last time I'll talk about specifics. All of these are reported in our blog. I'm reporting them in aggregate, which we haven't done. And this is only so I can make a couple of points about some patterns that we see across them. All right. So overall, I'm just going to plot them in this very, very coarse way. Green dots when the replication had a statistically significant result, red when it was in the ambiguous marginal zone, and purple when it's in the zone that most people would not refer to as marginal. And that's it. At some basic level, after 20,000 participants and a year of effort, that's the result. And so you can look at it and say, those are effects where we ran 2 replications and the original result replicated in both. Those 2 are ones where we ran 2 replications, and oddly, they both fall into that marginal zone. This is where each one had about 5 times the original sample size. And I would say, yeah, that looks pretty good too. And the other 3, these are complicated. So one of them was one that we identified a confound in the design that had not been reported in the original paper, but was present in the materials for the study. So it replicated, but for reasons that might be iffy. And those other 2 are ones where we ran 2 replications. One looked good, the other one did not. It's also worth noting that every single effect size that we estimated was smaller than in the original. Now that doesn't have to be a particularly bad thing, but it's not necessarily a good thing, or I would say it is necessarily not a good thing, but at the very least, that's what happened. And then we can point out that actually only 2 were in the wrong direction. Now that doesn't feel particularly comforting, but John Wickstead, for example, has made an argument that you can count up the number of findings that went the wrong direction in the original the 100 studies paper that I've already forgotten who the authors are on that. And he said, actually, that's a good sign that you can count up the number of ones that go in the wrong direction. There aren't very many. And so actually the field is more true than it looks. So maybe sounds good to me. There's also a lot of purple dots on that scatter plot, and purple dots are definitely not good overall. But as Joe and I, if you've talked to either of us about this, will tell you that the most interesting thing is not the scatter plot, it's all of the other interstitial things that happen in running these replications. And so we learned a bunch of other things. I'd say this one is the most practical, assuming that most of the audience are folks that run studies and they use online samples. I would say this is really important. Online data is okay. Authors over and over and again, if we fail to replicate their finding, the first thing they'll say is, I've heard that MTurk data is getting really, really bad. And there's just no particular evidence of that in ours. So manipulation checks always look great. And in fact, every time we're looking for internal fidelity of the studies or the instruments, they look okay. Furthermore, there's something existential in this, and that is that if we think MTurk data is broken now, then it's unclear what we're doing with all the other studies that aren't replications, because those are all based on MTurk data too. So I'd say online data, fine. Authors, even at the height of the open science movement, are not great about disclosing details. And that is true even for authors that are actively trying to disclose details, right? So they are posting materials, or at least trying to be as transparent as possible. That amongst the things that we almost always ask for are information about how participants were recruited, how much were they paid, how was the study advertised, but then also small things, that there are elements within surveys that could lead to potential issues that weren't there, exclusion criteria that weren't mentioned or weren't detailed sufficiently, right? And again, some of that is oversight, and And some of it might be like some form of p-hacking. And I don't mean that as an accusation. I mean it in the sense of, man, there's a whole history of our field not disclosing everything. It's hard to know in this case. Some threats to validity go beyond replication. This one does have some details, but I would say the biggest one I mentioned in the scatter plot, there's this one that had a confound that ends up being extraordinarily consequential. That is, when we remove the confound, the entire effect disappears. And it's only present in the materials, which were not posted, but had to be asked for. Right, so we did get them, so the authors, full credit to them for sharing their materials to us. But that's the sort of thing that is going to always be a threat to the validity of the original and is very hard for us to assess. Okay. Oh, a couple of other things that I credit to Joe for doing all of this, that for some of the analyses that are more complicated, that you can discover that they have inflated false positive rates that undoubtedly the original researchers don't know about because we didn't know about. But you can only discover it by digging really, really deep into the data and trying to replicate analyses to sort of see how that happens. Okay. Finally, regardless of all of these, and whether you take these 10 as representative, there's pretty strong evidence that at the very least studies have low statistical power. So our median estimate across all of those was that the originals had about 7% power, where the way we do it, 2.5% would be the floor. So 7% is higher than 2.5, but it's a lot lower than the 80% that is supposed to be our guiding principle, according to Cohen. So all of those are useful. I'm gonna slightly shift gears, but given that my panel is quiet, I will ask if there's any questions or any topics I should be thinking about. Don?
You're doing a great job, Leif. Keep on trying.
Thanks, Don. Great. Okay, so Joe and I would say we learned a fair amount from doing this, and it's possible all the things I mentioned are things that you feel like you already knew or so you didn't learn them. So we can sort of move forward and say, all right, what is the best way to learn from replications in general, right? So there was this time in the past where people didn't do replications very often in psychology or behavioral science. And so the first line of questions are replications ever valuable? And I kind of think we've graduated from that as a field. Like maybe there's someone who says replications are never valuable, okay, but I think that person's now in the minority. And so we can ask a different question, which is how can we maximize what we learn from the replications that are going to be done? And so how can we build a tool for the field to think in that way? And this will refer to this project I've been working on with Mike and Don. It's Mike's project, but Don and I sort of are engaged with it, so we're brought along for the road. Okay. So how should we aggregate knowledge in the field? Assuming that the field always wants to do that, right? We are intrinsically a cumulative discipline where the learnings of the past inform the learnings of the future. And I would say there's two broad, very distinct categories here. There's replication audits and there's literature reviews. So I'll talk about both, and then I'll talk about what we propose. So first, there's replication audits, and these, again, didn't exist 10 years ago, and now are or didn't exist to my knowledge in any real way, and now are fairly popular. And I'd say there's three broad categories here. There's the open science collaboration version, where you define a field, randomly sample it, and run lots of replications. And so that was amazing. And again, I would say for the entire field, amazing. Like really existentially informative. There's just one of their plots where they say the average original reported effect size was an R of about 0.3, and the replications have an R of about 0.1 or whatever it is. Great. An alternative is to say, no, I don't want a random sample. I want a selective sample. I want studies that people care about or they're wondering about the replicability. And so those are broadly in the category of the many labs projects. And so This is just the plot from the original one, which I'm going to grant the font size is probably a little small for you to see, given that I can't read it and it's my screen. But you've probably seen this chart before. And so there's a bunch of different studies going from anchoring at the top down to money priming and flag priming at the bottom, showing variation in both the original effect size and in the replication effect sizes across many different labs. And this is great too. These are, every time that these come out, it's always exciting to see what happened. And there's a third type, I would say, where you do a very deep dive on one particular paradigm. And there's lots of these that fall in the category of these registered replication reports. I'm highlighting this one that Mike was the lead author on, which looked at the Dexterhuisen van Knippenberg professor priming. And you get a chart like this, where a forest plot where you have the original estimate and then each of the estimates of all of the others. This is like a single line of the many labs, except with a really, really deep dive, because we're working with the original author to construct the ideal paradigm for testing this in each of the other labs, and it's all super duper structured and all of that. That seems good too. And there are other types of collaborative audit type projects that are interesting. So I am not an expert on all of them, but they're all different styles of learning deeply about this one thing or sampling from an array. And we can compare those to what happens in literature reviews. And there's lots of different types of ways to review the literature. I'm going to emphasize a couple. Okay, so replication audits, my summary. They can deliver a general sense of replicability. That's the random sample version. They can also tell us about some specific studies. That's either the many labs or the registered replication reports. But I'm going to argue that they're not necessarily great at offering a particularly utilitarian perspective, utilitarian sense for someone who wants to study a domain. So if I want to research in a particular area, maybe there's one study in there that got replicated. So if I want to study behavioral priming, I could look to the Dexterhuisen van Knippenberg replication and see what its result was. But if I don't want to study professor priming, in fact, I want to study the effect of older adult stereotypes on walking speed, it's not going to get me there, right? So useful narrowly, but not useful broadly. And so there's a good argument. That's why replication audits certainly weren't popular historically, as opposed to the alternative, which are literature reviews. So literature reviews come in two broad categories. I'll say that the first one is the qualitative review. This is the biggest category. And that's where someone goes, they read lots and lots of papers, they summarize them, they provide an organizing framework, maybe articulate a new theory that can explain existing findings, probably some boxes and or arrows, and completely plausibly useful. This has some potential problems. Here, my conceptual abstract of a paper that could be written, which I'll read because I have time and you guys are captives. Researchers have long wondered how long it takes to travel from Los Angeles to New York. We reviewed posted articles, personal narratives, industry reports, and introspective estimates to learn about this question. We identified three major determinants of transport time: time of departure, traveler mindset, and whether the traveler was walking or on a plane. Future researchers can investigate whether these forces differ in magnitude. This is how I see lots of literature reviews. They are inclusive. They do find patterns. But on the other hand, if you want to know how long it takes to get from LA to New York, it's not that helpful. And this is a domain, I obviously choose travel time because it's one that we do understand. We don't need a meta-analysis or a qualitative review to tell us about it. But imagine you didn't understand a domain. It was a truly novel area, right? And so maybe it's a literature review on behavioral priming, or maybe it's a literature review on willingness to pay or consumer preferences. We don't know enough to be able to differentiate big factors from small factors, or what's being left out or what's being kept in. And so they're great, but they don't deliver everything that we want, which in part gave rise to the quantitative meta-analysis. So the quantitative meta-analysis now goes through all of that literature, extracts effect sizes, and tries to combine them to create a single estimate of the answer to the underlying question. And so then you end up with something that looks like this. Researchers have long wondered how long it takes to travel from Los Angeles to New York. A PubMed algorithm identified every published article reporting travel estimates over that route. We subsequently contacted every relevant listserv to collect any unpublished reports on the topic. Finally, we did organic searches on the Open Science Framework for any paper using the keywords Los Angeles, New York, and travel time. We combined those estimates using state-of-the-art meta-analytic statistical tools. It takes 1.3 days to travel from LA to New York. This is how I see lots of meta-analyses. They are boastful of how inclusive they are. Look, we found all of these articles. We dug deep into the unpublished literature and found things. And then we put them all in a blender and we generated an estimate. Once again, when we think about travel time, and I say 1.3 days, you would all say, that doesn't describe any travel from LA to New York. If I fly, it takes a few hours. If I drive a car, it takes a few days. If I walk, it's definitely not obvious that it's anything less than infinity, right? And so we don't know what we're describing here. And so meta-analysis is trying to use the tools that we have to get to this answer. And it's hard, right? And I'd say they generate answers that are imperfect. It's not that I think all meta-analysis shouldn't be done. It's that it is an imperfect tool for what we often want to use it for. Okay, so my sense. Literature reviews provide a sense of breadth of the measures and approaches that are used in a field. I think that's great. They can offer a quantitative estimate of something, like in the form of a meta-analysis. But I'm going to argue that it doesn't tell us particularly well which researchers or tools are most important or most reliable within a field. And the estimate that they give us is biased because we only see in psychology, not in travel documentation, we only see significant results, right? So it's biased upward. And for all the tools that we have, and again, Joe and Yuri and I have even written about and published a tool designed to say, try to correct for this. It is still really hard, borderline impossible. And then the other part is that meta-analytic estimates are answering a question that I would say no one was really asking. They might not know that they're not really asking it, but when I say, what is the average travel time from LA to New York? You say like, no one wants that answer. If I say, what is the average effect of primes on behavior? That feels like it's like a reasonable question, but if it's actually describing travel times, it's not. It's insufficiently precise. Studies are too different. We don't need that estimate. Okay. That is my elaborate setup for this that we're going to offer. So what is a good alternative to either the lit review or the meta-analysis or even the replication audit? I don't want to abandon any of those tools, but I want to offer an approach that does something that is different. And so the empirical audit and review, which this term I'll use occasionally, this is this big project that I did with Mike and Don and all of those other people. I apologize that the font size is small, but it doesn't mean their contributions were small. They all did a ton of work on this. So it's really fun, big collaborative project. If someone wants to understand some literature, they want more than a list of what manipulations have been used or what measures have been found or what constructs relate them to each other. They want to know what people actually do. What are the actual designs? What are the sample sizes, if you will? And then they want to know, what does the evidence look like? So not just an effect size, but evidence, statistical power, replicability. Because if you know that, it allows you to build on it. If I told you that there was an elaborate literature review and a meta-analytic estimate or whatever, like everything, and then I said, actually, none of those findings replicate, the not replicating would be the most important information. Everything else would trail after it. So you want to know which studies within that domain have the best evidence. And if I'm a novice researcher, I want to find the ones with the best evidence because that's where I want to start. I want to say, oh yeah, great. That paradigm seems to have high power, reliable estimates. I'm going to build from there because it's a good foundation. You could also say, which ones have the weakest evidence? If you're an active researcher in this domain, and you see that there's poor evidence in some area, you might say, oh, that's an opportunity for me to make the most of this, and I can find the strong evidence. But it might also be where if you're a theorist, you want to know about that because you don't want to have the boxes and arrows include all of the findings that have weak evidence. You only want the boxes and arrows to include the strong evidence. Otherwise, it's a bad theory. Okay. And I would say existing reviews don't do that. And I would say existing reviews can't do that. It's not an oversight that they're not talking about strength of evidence. It's that evaluating strength of evidence is a hard task. And there's statistical tools, but most notably, there's the replication tool for working on it. So here's our approach. We identified a single literature that is internally diverse, but are all linked in some way. We're going to sample from it randomly, and we're going to try to replicate that sample. Yeah, Don, go for it.
Can you say a little bit about the selection of that literature? There were some questions that came through relatedly about how you and Joe selected articles for your data replicata replication effort. And if you're feeling particularly ambitious, you might consider the accusation that you're biasing your search for studies that may have overestimated their reported effect size because you're drawing from the published literature.
Excellent. Okay, working backwards. Because we are replicating studies that are in the published literature, almost certainly. They don't have to be overestimates, but on aggregate, they are going to be overestimates because of publication bias. And publication bias sounds like the kind of thing that we would all be dead set against, but publication bias is actually something that we live with. No one's fighting against, or not really fighting against, the idea that we publish significant findings because they have learned something, and null findings are published less often. We can talk about the details, but yes, that is the first level. And that is not me and Joe or us being particularly biased, but that is the nature of things. Now, when you think about how did Joe and I pick studies, Joe can answer that and probably will by writing. But it is true that we do not, in that one version, if we wanted to get unbiased estimates, we could look hard through the literature for those claims which were, if you will, obvious. And those are not core findings of papers, but they're often findings en route to something else. So study 1 shows that men are taller than women. Study 2 shows that if you prime people with shortness, that difference changes. You're like, okay, well, the priming is pretty heavy. That's the important part of the paper. But it's true, study 1 did show that men on average are taller than women. We could have tried for that, and so on. When it came to this domain, thinking about the empirical audit and review and Don's question, so we certainly didn't choose the research topic area, which I'll reveal to you in the next minute or so, based on its having low replicability features. We chose it because we were all interested in it. And as Don knows, I mean that literally across all 24 of us, that we thought about topics we could study. And our goal was not to find something that wouldn't replicate. If anything, my God, it is the opposite direction. But it is because we wanted to find something where everybody in our group cared. They said, oh, that is a hot topic. People are studying it. And the outcome of any investigation is intrinsically interesting. Now, it could be that those features are going to bias us. Maybe any topic where it's intrinsically interesting, everybody cares. Maybe that's biased towards high replicability or low replicability, right? And I don't know, but that is where we started. And so it is true that any approach, you need to say, why are we landing on this? Now, if you're in a content area, it's more obvious. So if you spent the last 10 years of your life studying willingness to pay, it makes a lot of sense that you would say, I'm going to do an empirical audit and review on willingness to pay, because that is your area. For Don and Mike and I and our co-authors, we're not researchers in this area. We are doing a proof of concept of this approach to understanding literature. And so for us, it's outside of our domain. And then from there, it's going to be all these other features. Don, that was a very elaborate answer to your question. Was it fine?
Satisfied me.
Thanks, Tom. Okay, so we're going to choose a literature, sample from it, and replicate it. The hope is that those replications can give a collective sense of that literature. They are not going to review all of it, and they are not going to offer an aggregate estimate effect size. What they're going to do is provide a general sense of what might be contained within that literature. So here's the one we approached. We looked at the psychological consequences of scarcity. So the short setup to this, poverty is obviously hugely consequential and has been since forever and continues to be, both within the US and beyond. And many, many of the consequences of poverty are transparent and unambiguous, and entire government structures can and should be put in place to work to improve those. So we're concerned about lack of nutrition, lack of access to housing, inability to invest in education, and so on. Okay. And so people have studied poverty for a long time, and people have studied scarcity in different ways for a long time, but the sort of key turning point came in work that Sendhil Mullainathan and Eldar Shafir have done, where they looked at the idea that actually the sense of scarcity can have consequences that are beyond those direct practical ones, but are more psychological. And so that it might impede cognitive function in one way or another, or alter how people think about different things. And this gave rise to a very, very large, very active research area. Okay, for those of you in my local field of consumer research, you will know, in fact, this is one of the hottest topics in JMR and JCR over the last few years. And in fact, the journal of the Association for Consumer Research, the JACR, had a special issue entirely devoted to this topic just last year. Okay. All right, so we want to look at that. A lot of what I'll talk about are just procedural minutiae, but I think they're interesting. We wanted a definition of the field. And it could be that someone who's an expert would have an intuitive sense of what should be included. But we didn't really want to rely on intuitive sense. So we came up with an operational definition that could be replicated by anyone else for what would be included in the set. Here's our approach. We start with a seed, and we say the first empirical demonstration in this domain we will define as being this paper by Shah, Mullainathan, and Shafir, which is published in Science. And we say any paper that cites that paper could be included. So right off, we should say papers that were relevant that came earlier won't be in our set. Papers that are in this domain, but for whatever reason don't cite the seminal work, we won't catch them either. But we will catch everything else. And so this paper is cited a lot. This is Web of Science, 392 citations, great. And we get a big list. These are all the papers that cite it. Now, of course, not all of them are experiments. So we look at them. In this point, we read them, all the papers. And we say, does it report an experiment? Many do, many don't. Some are just review papers that are reviewing something. And you say, great, we can't use those. Then we say, can those experiments that are reported, could they be conducted online? So in this domain, Most of them were conducted online. A few weren't, of course, and some of the ones that weren't could be conducted online for one reason or another. But mostly they were conducted online. But we can only collect online samples, so it is a constraint for us, and I'll return to this later. Then we also ask the question, which ones are actually studying scarcity? Because just because you study the scarcity, you cite the original scarcity paper doesn't mean you're actually in that topic area. And so we identify that also. And so we document all of these decisions. Then from that final set of papers, now we actually do the random assignment, and we're going to select 20 of them. I don't have the visual aid here, but we really drew balls from an urn in order to do the random assignment, which feels kind of neat. If you're in a judgment decision-making researcher, we talk a lot about urns and a lot about the balls in them, but we never really do it physically. This was physical balls in an urn, and we randomly draw papers and then randomly draw studies from within paper, and then go on from there. This final bullet point is all the things you would have anticipated. The sample size is 2.5 times the original. Everything's pre-registered. We use original materials when possible. We contact authors when the original materials aren't available, and there's open questions and so on. Great. And we end up with this list. That's also in small font. And if you read really, really fast, you can read through and be like, hey, I am that person, or I know that person, or I read that paper, or in concept, all of the above. But I'm not going to worry about it. I will, in this case, talk about a couple of individual studies, but as you'll see, that is not where the emphasis is. These are our 20 studies. And I'm just going to show you what we found, and I'm going to show it to you in pieces, then I'm going to unpack it very briefly. So I'm just going to plot the effect size of the original and the effect size that we observe in our replication. And they're sorted based on our estimate of the statistical power of the original. Okay, so what does that look like? Let's just take this one at the top by Cho et al. Okay, so if you look at it, you'll see that that green dot, that's our replication estimate, where we estimated the effect size in our replication was about 0.21. The original was reported an effect size of about 0.18. Okay, that's step one. Step two, those little icons to the left, those are our characterizations of kind of what that study is like. In this case, it's pointing out that the manipulation was directly related to money or the economy. That was how it instantiated scarcity, and that the independent variable involved a writing task. It also says the absence of that diamond shape suggests that the dependent variable was not related to a financial decision. In this case, actually, it was related to experienced pain, which is all kind of interesting. And then these other estimates over here, we estimate based on the effect size that we observed that the original had 90% statistical power. And we say if someone wanted to study this themselves, they would need a sample size of 200 people to study it. Cool. So we're all oriented to the chart. Great. Now I'll show you the rest of it. So there it is for all of them. And you can read through and you can sort of look at each individual row, and you get something from our green blue dot and from the red orange triangle. And again, I told you ahead of time that they're sorted by estimates of power. And so you see at the top, there was the one we just talked about that had 90% power. And as you get down towards the bottom, they approach 5% power. And then the ones on the bottom, the reason they're in red is that the estimate that we observed was in a direction that was different from that of the original. And so our best estimate of their power for their hypothesis is that it is less than 5%. Okay. All of which is fine. So we could look at it, and obviously we are, and say, well, first of all, how many of them were significant in the replication? And of the 20, 4 were, which is both considerably more than 0 and considerably less than 20. But I would say that's not the big story. It's not the interesting story here. It would be doing a disservice to the project if that's all we looked at. We could also say, well, the median estimate of statistical power of the original studies is that they had about 10% power. And that if you wanted to study those effects, you would need about 5,000 participants to have 80% power. Again, informative, but not the big story. We don't need to think in aggregate. Thinking in aggregate is where we get lazy. That's what happens where you say, you miss all the nuance that's in a field. And so we can actually look at this as though, yeah, we have some aggregate sense, but if I really wanted to study scarcity, I wouldn't care about what is the average effect size or what is the average statistical power. I would want to know, of those studies that are well-powered, what are they like? And so you might look at one of those. So just as an example, I'm going to focus on this one briefly by Cook and Sadeghian. I apologize if I'm mispronouncing the name, which I almost certainly am. And you can see that it was significant in the original. Actually, as it turns out, it was not quite significant in the original. It was about a p-value of 0.07 or something, but it was significant in our replication. And the short version, this is my 30-second summary of theirs, is participants were asked to imagine themselves in one of 8 different scenarios. So it's a 2 by 2 by 2 between subject design. And they're asked how much money they would seek from a payday loan that is a high interest, generally speaking, ill-advised loan. Some people are told, you are currently broke, or other people are told, you just got paid. They call that financial liquidity. They're also told, your car is about to be repossessed in one condition, and another they say, you have interest in buying a new car. And then finally, they're told, you can get a loan someplace else besides the payday loan, or they say, you have no other loan options. The payday loan is your only option. And then they say, how much money would you seek from a payday loan? And they predict that one cell will be different from the rest. That is, people who have no money, their car is about to be repossessed, and they have no other loan options, that those people will seek out a payday loan or more from a payday loan than will the other people. And they find it. Well, again, about 0.07. But the black bar furthest to the right, that is that cell. And you can see that that is a much higher estimate than the others. It's kind of an elaborate pattern there, but here's our replication. You see, we also observe that. And so the original authors refer to this as the triple scarcity effect, where you need all 3 of those factors to get to the payday loan seeking. And we observe approximately the same, right? So if you want to step into this literature, you might have a paradigm that you wanted to work with. Okay. What about the rest of it? Now you can look at it and you say, if you're looking carefully at this chart, and I hope the chart is interesting enough that when I'm presenting it, all of you kind of enjoy staring at it, you might notice way, way down at the bottom is this interesting one, where the original was significant in one direction, and it's hard to tell, but our replication was about 0.04 p-value in the wrong direction, or in the opposite direction, if you will. And so if you wanted to study this domain, you might say, what's going on there? Is it just noisy? Or maybe I want to study what changed there. Is there a moderator? Or is that replication that went in the opposite direction? Maybe that's the finding I want to replicate. So we could ask, what's that? And here, I'll just briefly describe this study. So all participants, they measured individual differences in risk aversion. You'll pardon me for not knowing how they measure it, and Don will be the first person to articulate. Actually, there is no stable measure for risk aversion, but they have one that they use in this. They then watch a slideshow indicating that there's going to be an economic recession coming up or an economic upswing. And then they ask them, if you had children, a boy and a girl, how much money would you bequeath to them when you die? And the authors hypothesize that if you are, well, you can see the pattern. Basically, you're more likely to bequeath resources to a girl offspring when there's an upswing, but only if you are high in risk aversion. So that's the pattern. And it's a little subtle. I don't have any intuition for this effect. I had a lot more intuition for why people would seek a payday loan when they didn't have money and it was their only option and their car was about to be repossessed. This one's harder for me. And so what do we find in our replication? And we can look at it and we say, oh, it's visually different, obviously. And the interaction is clearly not in the same direction. And someone could look at that and say, that looks like noise, or maybe they want to study it because they care a lot about patterns in bequeathing behavior and hypothetical bequeathing behavior. But those are just two samples. And again, we have the whole literature. The goal is to be able to think about the scarcity domain in this case in a way that doesn't just resort to an average and doesn't just assume everything is tied for equally related and equally contributing. That we can look at it and say, maybe if I'm going to build a theory that explains things, I'm only going to look at the top of the chart. Or if I want to say where are the most hard to answer questions, you might say maybe that's the bottom of the chart, right? And so we can approach it that way. And so my short conclusions in these last few minutes, when I think about scarcity studies, we saw modest replicability, so not super high. I don't think this is the big story, but it's a story. Because I'd say the bigger story is that some studies look great. And I would have said, if we want to build a discipline, that's a great place to build our foundation. Imagine we could do that for every other literature in behavioral science. That if we think some findings won't replicate, we think they're not true, if you will, we would love to identify those so that we can build a theory out of those that will, because that's the stuff that is going to be a good theory going forward. And so this provides us that first step that it's not that everything is broken, it's that some things look potentially problematic. We didn't replicate every study. And so an optimist could say, the selection bias for being in our set, you cited that paper, you had an online sample, and it was explicitly about scarcity or whatever. You say, that is a bias against where the true core of the discipline is. So maybe it is the case that the ones we couldn't do, elaborate field experiments that are conducted in hard to reach foreign countries, maybe those are the true effects. And so we might say we should reorient to those domains, possibly, right? And so we can think about what is missing and how we approach that. My general conclusion about this approach, the empirical audit and review. Our field, and here this can be drawn all the way from consumer research up through behavioral science, up through science, like big category, is all about trying to be cumulative. Right? We learn from the past to make better predictions for the future. Publication bias and error make it hard to accumulate. We don't know what we're supposed to accumulate. This approach allows us to find the pieces to accumulate. It allows us to actually have a cumulative science. So if we can operate in cumulative ways, then we can start thinking in terms of what comes next. Now our foundation is true and replicable, and so we can say, let's find out what we can do. And I would say it can be applied to any domain where someone might otherwise have just done a traditional literature review or a meta-analysis, right? To any domain where there's empirical content that you want to aggregate in some way. And then my last slide here about the conclusion, about the value of replications, I would say on the surface, replications always feel like, almost by definition, the smallest possible contribution to a literature. And I'm trying to make, and I'm not unique in making this argument, that they can be extremely important because their contributions are necessarily practical and fundamental. If we move past that initial debate about whether replications are useful, we can now start saying, how can we make them as useful as possible? And obviously, I've made my pitch with in these different approaches for how to maximize the utility we get from replications. But I think empirical audit and review it can be quite useful. So it is always going to be the case that new research, novel findings, non-replications, if you will be super important. But being systematic and detailed in replications allows for those original contributions to maximize their value, right? Because it means that we know that we're only going to move forward with the findings that are robust and reliable and make valid, consistent predictions. And so I think that's pretty useful. So I will, I think, end there. Great. Thanks, everybody.
Thanks, Leif. I think we have time for a couple questions, if there are any. One that Caleb Warrens just submitted through the Q&A is about basically the study that you went over that replicated doesn't seem terribly surprising, but the one that you went over that didn't replicate or that replicated in the opposite direction or something, that one seems pretty surprising. Like, do you think that I guess there's two questions here. I mean, his question is, do you think there's a problem with the premium that the field puts on surprisingness as sort of a thing that you want to have in order to publish? And then another question I sort of had related to that was like, did you guys make predictions about what would replicate prior to that? And were you like, did what replicated, like, did that sort of gel with your intuitions or not really?
So there's a lot in there. And my short answer would be, we didn't do predictions for this one. As it turns out, Don and I are working on a project right now, another empirical audit and review, and we are doing predictions for that. I share Caleb's intuition that the first one is a little less surprising of a finding than the second. And I will say, should our field disincentivize surprising results? And I would say absolutely not. I think surprising results are great. They move the field forward fast. The downside is deprioritizing evidence. And so conditional on findings being true and surprising, that's the good stuff. And I will say to that, I highlighted the paper by Cook, but the very first one, that paper by Cho et al., that is a paper showing that if you ask people to think about a time when they had scarce resources, that's part one of the experiment. Part two, they asked them, to what extent right now are you experiencing back pain? That is very surprising. So we replicated it, and it replicated perfectly, as you saw. And then, because I was like, is something wrong with our replication? Mike and I ran another replication of that, and it worked again. So I would say that is surprising and true. And so there's going to be pieces like that, and I think it's great when those exist. And I have no idea what the explanation is. You can ask the original authors, and by all means, tell them I told you to do so, because I think their paper must be amazing, because it still confuses me. I hate to do it, but we're at time, and I never go over. Is that okay, Joe?
Yeah, sure. Yeah, feel free to, some of you have other great questions. I'm sure Leif will be happy to hear from you if you want to email him. All of the questions we'll get back to Leif, of course. Thanks so much to all of the panelists for coming today. Thanks to all of you for attending, and we will see you again. We're on with Deborah Small next week, so we'll see you then. Take care, everyone.
Thanks, everybody.